This lesson is secants, tangents, and angle measure. We're going to solve problems involving secants and tangents that intersect inside or outside of the circle and see the relationships between the angles and the arc measures. So the interior angle theorem says that angles that are formed by two intersecting chords are interior angles. And when that happens, here's the theorem. The measure of the angle formed by the two intersecting chords is equal to half the sum of the measures of the intercepted arcs. So, if you consider angle 1 and angle 2, they intercept arc AC and arc DB. Since angle 1 and angle 2 are vertical angles, you know that they're congruent anyway. But the measure is half of the sum of the arcs. So the measure of angle 1 is equal to half of the sum of the arcs. That'll be the measure of arc AC plus the measure of arc DB. So when the intersection is inside, the angle measure is half the sum of the arcs. If you want to write it in an even briefer form, you can say when the segments intersect inside, then the angle is equal to half of the sum of the arcs. So let's look at this example. We're going to find x and y. Well, I have two intercepted arcs here, and those arcs, that's what the angle at x opens up to, and what its vertical angle opens up to. When these segments intersect inside, then the angle measure is half the sum of the arcs. So the angle is half of the sum of the arcs. So the angle is x, and that's half of the sum of the arcs, and that'll be 91 plus 85. When the intersection is inside, these intersect inside the circle, the angle is half the sum of the arcs, and half of 91 plus 85 is 88 degrees. So that's x. If you look at the picture, y and x form a linear pair, so that means that 88 plus y equals 180 because linear pairs add up to 180. So if you subtract 88 from 180, y is 92 degrees. But sometimes you need to take it a step further there with a linear pair or with vertical angles or something like that. Just take that extra step of logic to get what you need. But when the intersection is inside the circle, the angle is half of the sum of the arcs. Sometimes the intersection is outside of the circle, on the exterior of the circle, like these three situations. You could have two secants. Remember, a secant hits a circle twice. The top segment hits twice, the bottom segment hits twice. The intersection is outside the circle. You could have a secant and a tangent. Remember, a secant hits twice and a tangent touches the circle once. Or you could have two tangents. Each tangent hits the circle once. In all of these cases, the intersection is outside the circle. The intersection is outside the circle. And when the intersection is outside the circle, then the angle is equal to half of the difference of the arcs. So when the intersection was inside, the angle was half the sum. Now it's half the difference. And when it's the difference, you do the larger arc minus the smaller arc. So it'll be the arc that's further away from the angle minus the one that's closer to it. When the intersection is outside, the angle is half the difference. So here's some pictures if you want to be a little bit more specific. In this first one, the intersection is outside, so the measure of angle 1 is half of x minus y, half of the difference. X is the bigger one, minus y, which is the smaller one. Measure of angle 2 is also half of x minus y, half of the difference. The intersection is outside, it's half of the difference. X is the larger arc, y is the smaller arc. And the measure of angle 3 is the same thing. It's half of the difference, x minus y. Now keep in mind with these arc measures, we're dealing with a circle, and you might end up using the whole circle. And there's 360 degrees in the whole circle, so be prepared for that. So let's find the measure of angle ACB. Angle ACB has an intersection outside the circle, and when the intersection is outside, the angle is half of the difference. So the angle is the measure of angle ACB equals half of the difference. That'll be the big one minus the small one. 265 minus 95. And half of 265 minus 95 is 85 degrees. When the intersection is outside the circle, the angle measure equals half of the difference of the arcs. How about this example? They give you this circle with all of these segments. Segment AF is a diameter. The measure of arc AG is 100 degrees. The measure of arc CE is 30 degrees. And the measure of arc EF is 25 degrees. Let's find the measures of all of the angles. So you can go out of order or in order, however you end up seeing things. One thing I see right off is that angle 2 is a central angle that intercepts this 100-degree arc. So central angles are equal to the arc, so that's going to be 100 degrees. That's an easy one. I can also see that angle 1 and angle 2 form a linear pair. Linear pairs make 180, so I know that the measure of angle 1 is equal to 180 minus 100, and that's 80 degrees. So that'll be 80 degrees there. Measure of angle 3, well, angle 3 is an inscribed angle because the vertex is on the circle, and the inscribed angle intercepts arc CF, which is 30 plus 25, or 55 degrees. The inscribed angle is half of the arc, so the measure of angle 3 is equal to half of 55. The inscribed angle is half of the arc, and that's 27.5 degrees. Angle 5 here, it is inside the circle where these two segments intersect. And these two segments also intercept the 25-degree arc and the 100-degree arc. When the intersection is inside the circle, the angle is half the sum of the arcs. So angle 5 will be half the sum of those two arcs. Measure of angle 5 equals half of the sum, and those arcs are 25 and 100. Remember, when the intersection is inside, the angle is equal to half of the sum, and that's what I did here, and that's 62.5 degrees. Angle 5 and angle 4 are a linear pair, so I know that they add up to 180. So angle 4 is just 180 minus angle 5. So that'll be 117.5 degrees. Angle 6 is formed by these segments that intersect outside the circle, and they intercept the 30-degree arc and the 100-degree arc. When the intersection is outside, remember the angle is equal to half of the difference of the arcs. So the measure of angle 6 is equal to half of the difference, and do the larger one minus the smaller one. That'll be 100 minus 30. So half of 70, which is 35 degrees. So the inscribed angle is half of the arc. When the intersection is inside the circle, the angle is half of the sum of the arcs. That's what we did on 5. When the intersection is outside the circle, the angle is half of the difference of the arcs, and that's what we did on 6. And then sometimes you have linear pairs where they add up to 180 and so forth. So make sure you're using the correct rule. Whereas the intersection, inside is half the sum, outside is half the difference.